Imagine this, the late 19th century, say 1882, America. A young gentleman named Arthur has arrived in Chicago on business. He's confident his meeting is scheduled for 10 a.m. according to the time in his hometown, Omaha. He sits calmly in a coffee shop, sipping his second morning ale and glancing at his pocket watch. It's 9:45. 15 more minutes. Suddenly, a breathless courier rushes past, yelling, "Your train already left, sir, 10 minutes ago." Arthur is stunned. His precise watch, synchronized with the local bell tower, shows something entirely different. You know, this was typical for that era. Every city, sometimes even every train station, had its own local solar time. Clocks in Boston, New York, and Chicago show different times. Each location lived by its own rules. Chaos? Absolutely. Physicists of the time would probably have chuckled, "Oh, come on, it's just a time difference. Get used to it, folks. The Earth is round." By the way, if you're already curious where this madness is headed, don't forget to like this video and subscribe to the channel. Your support truly means a lot to us. Also, we're always curious to know, which city and time zone are you watching our lectures from? Let us know in the comments. We'd love to read about the geography of our shared now. Let's get back to our clocks. What if I told you that even today, in your era of smartphones and atomic clocks, your watch, yes, your watch, the one on your wrist or phone screen, is actually lying? And not just lying, but showing a time that isn't truly yours. Imagine, you're sitting in your room watching this video, and at this very same moment, literally in the next room, time, true physical time, flows ever so slightly, microscopically differently. Utter rubbish, someone might exclaim skeptically. That's nonsense. Time is universal, it's the same for everyone. And that's where you'd be wrong. Our familiar notions of time are like a flat map of the world. It's convenient, it helps us navigate, but it entirely fails to convey the full complexity and depth of reality. We grew up thinking that time is an invisible river flowing at the same speed for everyone, everywhere. From birth to death, the same current for you, for your neighbor, for the cat sleeping on the couch, and for the Andromeda galaxy. Tick-tock, constantly, unchanging. Right? Alas, this notion isn't just outdated, it turned out to be fundamentally wrong. It's as inaccurate as believing the Earth is flat and the sun revolves around us. Forget about this universal river, because in reality, time isn't one river. It's an entire ocean, with billions of its own unique currents, whirlpools, and even calms. At every point in this ocean, there's its own rhythm, its own unique, incomparable, personal tick-tock. Yours, mine. And even this sheet of paper lying on the table. Every point in space has its own time. And that's exactly what we're going to explore now. Get ready. This will be a very strange and fascinating journey. Imagine Cambridge in the late 17th century. The sun is setting over the English meadows, and Isaac Newton is perhaps strolling through his garden or sitting by the fireplace at Trinity College, contemplating his laws. For him, the world was a gigantic, perfectly calibrated mechanism, where time had its own master chronometer. Time, according to Newton, was like an invisible river, flowing uniformly, smoothly, and absolutely identically for every corner of the universe. No matter where you were, in London, on the moon, or somewhere in a distant galaxy, every tick of the clock was synchronized. A single, unshakable, absolute tempo of existence. By the way, If you, like me, enjoy diving into such amazing facts, don't forget to like this video and subscribe to the channel. It really helps us create more content like this. And also, we're very curious. Which city and time zone are you watching our lectures from? Let us know in the comments. We'd be interested to know. Now, let's return to our clash of titans. For over 200 years, humanity lived with this convenient and understandable concept. Time was just a backdrop against which all events unfolded. It didn't depend on anything. It simply flowed. Like a train speeding along tracks at a constant velocity, regardless of who's on board or where they're going. You're part of that train. Your time is the time of the whole train. Simple, logical. And then, listen, in the early 20th century, a young patent clerk named Albert Einstein steps onto the stage. He says, "Newton, I respect your work, but about that tick-tock of yours, there are some nuances." Imagine the reaction. Physicists of the time must have been scratching their heads, or maybe rolling their eyes, thinking, what utter rubbish is he talking about? Time is just time. But Einstein was relentless. He proposed an idea that turned everything upside down. His ingenious insight, time isn't a universal, independent metronome dictating the pace for everything. No, time is more like an elastic band that stretches and contracts. And how it stretches or contracts depends on how fast you're moving or how strong the gravity is around you. It was as if Newton saw a huge grandfather clock, ticking uniformly for everyone in the living room. But Einstein came along and said, what if everyone in that living room had their own wristwatch, and each one ran a little differently, depending on how fast they moved around the room, or even if they stood next to a heavy bookshelf? It was a genuine shock, because it meant time was no longer absolute. It was relative. It was part of a much larger tapestry, woven from space and time itself. Imagine, it was as if you had always thought a road was just a flat line, and then you were shown that it was a complex three-dimensional network that could bend, stretch, and even twist. Just mind-bending, right? But it was this crazy idea that became the foundation of modern physics and changed our understanding of the universe forever. From Newton's ideal master chronometer, we transitioned to thousands of personal, unique stopwatches. And that's exactly what we'll discuss next. Imagine this. October 22nd, 1971. 4 ultra-precise atomic clocks, each costing as much as a small airplane, are carefully loaded onto regular commercial airliners. 2 fly east, 2 fly west, circling the globe. The plane cabins hum. Flight attendants serve meals, and inside these sealed containers, an invisible revolution ticks away. This wasn't just a flight. It was a daring experiment designed to test something that had previously seemed like pure science fiction. That time for each of us isn't just a universal backdrop, but a personal, unique adventure. Before we delve into this incredible experiment, if you enjoy this deep dive into the mysteries of the universe and want to learn even more fascinating facts, don't forget to subscribe to our channel and like this video. Also, we are very interested. Which city and time zone are you watching our lectures from? Write in the comments. We'd love to read about the geography of our audience. Let's return to our clocks. These flying clocks, unlike their ground-bound counterparts that remained in Washington, were expected to return younger. Yes, you heard that right. What utter absurdity, a skeptic might exclaim, sipping their morning coffee. A clock is a clock. A minute is the same everywhere. But no, listen closely. In our universe, where good old Einstein calls the shots, speed isn't just about how fast you run for the bus. Speed is your personal passport to another dimension of time. The faster you move relative to someone else, the slower time flows for you. It's like a video game where one player suddenly switches to slow motion mode, while everyone else races at normal speed. And that's exactly what happened with those atomic clocks. When the planes landed, their onboard chronometers differed from the ground-based ones by tiny, almost imperceptible, but absolutely measurable fractions of a second. The clocks that flew were behind those that stayed on Earth. They had experienced slightly less time, tiny fractions of a second, but they were there, and it changed everything. Now imagine our astronauts. They're not just flying on a plane, they're hurtling through orbit at speeds of about 28,000 kilometers per hour. That's dozens of times faster than the fastest passenger jet. During a mission on the ISS, which can last for months or even longer, astronauts experience the same effect. For them, time truly flows a little bit slower than it does for us, standing on solid ground. And that's not a figure of speech, not a metaphor, it's reality. So, when an astronaut returns after a long stay in orbit, he or she is literally younger than their siblings or friends who remained on Earth. Of course, the difference is microscopic, just fractions of a millisecond, but it's there. For them, time isn't a strict conductor, beating the same rhythm for the entire orchestra of the universe. It's more like a jazz musician who, in their own part, allows for small improvisations, slightly speeding up or slowing down the tempo, depending on how fast they're moving. It's amazing and a little bit unsettling, isn't it? And this is just the beginning. Because speed isn't the only factor that can steal your seconds. Gravity? Oh, gravity. That's a real time thief. But we'll talk about that a little later. Imagine this. December 1915. Europe is engulfed in World War I, hell reigns in the trenches, and somewhere in the rear, in a German hospital on the Eastern Front, lies Karl Schwarzschild, an astronomer, physicist, and genius, ill with Russian flu. Instead of groaning in pain, he, suffering from a fatal illness, literally on his lap, between reports from the front and pulse checks, solves Einstein's incredibly complex equations. Just a month earlier, Einstein had just published his general theory of relativity, and now Schwarzschild sends him a solution. A solution that showed gravity can be so strong that it literally devours space and time. Imagine, cannons roar on the front, while this man opens a gateway to a world where time flows like caramel. Before we dive headfirst into these gravitational paradoxes, if you like what you're hearing, don't forget to subscribe to the channel and hit that like button. It really helps us keep going. And by the way, we're extremely curious. Which city and time zone are you watching our lectures from? Write in the comments, we'd love to know. Now, let's return to our black holes and their incredible ability to toy with time. So, Schwarzschild, essentially, opened the door to a world where gravity isn't just the force that keeps us on Earth. It's a true time eater. You're probably used to gravity pulling an apple to the ground, but for it to slow down the very flow of time. Sounds like the premise of a sci-fi movie, doesn't it? Some skeptic might immediately say, that's utter rubbish. Time is just time, universal for everyone. But imagine this. Time isn't just a hand on a clock. It's a river, and gravity is a giant boulder thrown into that river. The bigger the boulder, the stronger the whirlpool it creates, and the slower and more winding the current becomes around it. And where are these boulders the largest? That's right, near black holes. With these cosmic monsters, gravity is so monstrous that it literally bends space-time around them to unimaginable limits. There, near the event horizon, that invisible boundary from which there's no return, time begins to flow, not just slower, but unimaginably slowly. Imagine this scenario. You travel to the edge of a black hole, spend just a couple of hours there, admiring the cosmic beauty. You return home, and surprise, millions of years could have passed on Earth during that time. Your friends, your grandchildren, your entire civilization, all could have turned to dust. Frightening, isn't it? Or on the contrary, enticing. The possibility of living through entire epochs while remaining almost unchanged. Essentially, gravity doesn't just steal your seconds. It stretches them out like chewing gum, making each of your moments incredibly long by the standards of the rest of the universe. It's as if you were watching a movie at 0.0001 speed, while the rest of the world rushes by at 1,000. So, if before we talked about how speed affects time, now we see that mass and its gravity are also keen to toy with your clocks. And these aren't abstract equations on paper. This is what's happening right now, out there in the depths of space, turning millions of years into a single cosmic breath. December 1st, 1884, Washington, D.C., the International Meridian Conference. Imagine the hum of voices, the smell of cigars and ink in the hall, where delegates from 25 countries gathered. Their task, it seemed, was simple: how to synchronize a world where every city lived by its own local mean solar time. Trains were late, schedules got confused, people were driven crazy trying to agree on meeting times. It was a desperate attempt to bring order. But even when they agreed on Greenwich as the prime meridian, they were essentially admitting synchronization is just a compromise. We imposed a unified time because it was convenient for our logistics, not because it was true for everyone. Before we continue our deep dive into these mind-boggling concepts, if you like this video and want to learn more about the universe's most astounding mysteries, don't forget to like and subscribe to the channel. And which city and time zone are you watching our lectures from? Write in the comments. We'd be very interested to know how far our community reaches. So, let's return to our compromise. If in previous sections we discussed how time can speed up or slow down, astronauts age slower, and near a black hole, seconds turn into years, what does that imply? It implies that there is actually no universal time that flows identically for everyone, everywhere. Wait a minute. Some skeptic might say, my watch shows the same time as my neighbor's. Well, yes, because you're in the same gravitational field, moving at the same speed, within the same time zone. It's like a large pond where the water seems calm. But step outside the pond, and the picture changes. Imagine that time isn't one universal river, but billions of tiny streams, each flowing at its own speed. Each one reacts to the surrounding landscape, to the force of gravity, to the speed of movement. Your time is your personal playlist, unique to you. My time is mine. And the Andromeda Galaxy has its own unique tick-tock. Physicists are like, yes, exactly. It's not madness, it's the consequences of relativity. Every event in the universe has its own unique temporal fingerprint. It depends on where it happened and how it's moving. This isn't just a philosophical concept. It's a rigorous mathematical reality. So when someone talks about world time, they're talking about standardization, convenience, an attempt to reconcile these billions of streams into something manageable. But deep down, on a fundamental level, time is a local phenomenon. It's tied to you, to your position in space-time. It's like a shadow that changes its shape and length depending on the light source and the object. There's no single, unchanging shadow for everything that exists. No single, unchanging time. That changes everything, doesn't it? Our intuitive understanding of time as a metronome that beats a single rhythm for the entire universe is shattered. Instead, we get a complex, pulsating tapestry where every moment is as unique as a snowflake. December 1956. In the cold, electrically humming laboratories of the National Bureau of Standards in Washington, a team led by the brilliant physicist Chien-Shiung Wu conducts an experiment that would turn the world upside down. Inside a cryogenic setup, cooled to fractions of a degree above absolute zero, tiny nuclei of radioactive cobalt-60 decay. And that's where things get interesting. The decay products, electrons, fly out not chaotically, as expected, but prefer a specific direction. The universe, it turned out, is not mirror symmetrical. It, like an awkward dancer, confuses left with right, exhibiting a distinct asymmetry that no one had ever imagined. It was like discovering your reflection in a mirror suddenly looked slightly different from the original. Not just strange, but terrifyingly fundamental. Listen, if you still haven't liked and subscribed to our channel, you risk missing even more mind-blowing discoveries like these. Seriously, we're turning the universe inside out here. And what about you? And since we're talking about space and time, tell us, which city and time zone are you watching our lectures from? Write in the comments, we'd be interested to know. Now, let's get back to our quantum wonders. We've already established that time can flow differently depending on gravity and speed. But what if I told you that at the micro level, where quanta rule, time doesn't just stretch. It behaves like a whimsical child who can easily confuse up with down, and more importantly, start moving backward. What nonsense, you might say. Time always flows only forward. That's as obvious as water being wet. And you'd be right, in our macro world. Our intuitive sense of time is always a movement from past to future, like a train on tracks with no reverse. But in the quantum microcosm, these tracks suddenly begin to branch, and sometimes even disappear entirely. Imagine you're observing the movement of billiard balls. You can easily picture them rolling, colliding, and scattering. And just as easily, you can imagine this process running in reverse. The balls gathering back into a pyramid. This is called time symmetry, or T-symmetry. In classical physics, most processes were reversible, but when it comes to fundamental particles, that's where the real magic tricks begin. Here's another analogy. If our macro world is a movie that always plays from beginning to end, then the quantum world is the same film, but its individual segments can easily play in reverse, or even be spliced, in such a way that you can no longer tell where the beginning was and where the end. Physicists have discovered that at certain scales, the universe possesses astonishing symmetry. If you could rewind time for a subatomic event, it would look just as natural as moving forward. This doesn't mean we can travel through time, no. Don't immediately fantasize about meeting dinosaurs. It merely tells us how fundamentally different the nature of time is at the particle level. There's no rigid arrow of time that always points forward. Rather, it's a pile of autumn leaves that the wind scatters first one way, then another, and sometimes even in circles. Remember Wu's experiment, where the universe preferred left over right? This is called a violation of spatial parity, or p-symmetry. But there's also the CPT theorem, which unifies charge symmetry, c, parity, p, and time, t. It states that if you simultaneously invert charge, parity, and time, the laws of physics remain unchanged. And that means if one of these symmetries is violated, for example, as in the left-right case, then somewhere else, there might need to be compensation. And this compensation sometimes affects the very nature of time. So when we talk about quantum tick-tock, it's not just about stretching time. It's about reimagining it at the deepest levels. It's like a juggler who not only tosses balls, but changes their shape and color mid-air. And that means the concept of every point having its own time becomes even more dizzying. Because it's not just about the rate of flow, but also its very behavior, its fundamental properties, which can be so strange that our minds can barely grasp them. Think about it. Your personal time doesn't just flow uniquely. It also obeys rules where left might not be the same as right, and forward isn't always the only direction. And that's just the beginning. Imagine this, November 1st, 1755. A quiet, overcast All Saints' Day morning in Lisbon. Thousands of citizens, from paupers to noblemen, filled the churches. The air was thick with the scent of incense and the anticipation of the holiday. And suddenly, the ground beneath their feet began to dance wildly. It didn't just tremble, it surged like a raging ocean. Church bells began to peal their own eerie requiem, not by the will of any ringer. Buildings that had stood for hundreds of years crumbled into dust and rubble in a matter of minutes, burying tens of thousands of people beneath them. Then came tsunami waves, followed by fires that raged for several days. This wasn't just a natural disaster. It was the Great Lisbon Earthquake, an event that shook not only the ground, but also the foundations of European philosophy. How could a merciful God allow such a catastrophe on a holy day? It forced the greatest minds of the era, Voltaire, Rousseau, Kant, to question the ideas of predestination and divine fate. Freedom or fate? That was the question that hung in the air over the ruins of Lisbon, and which, strangely enough, is very closely linked to our topic of non-uniform time. By the way, if you, like us, are thrilled by such dizzying ideas, don't forget to like this video and subscribe to the channel so you don't miss new lectures. And, since we're talking about time and space, tell us, which city and time zone are you watching our lectures from? Write in the comments. We'd be interested to know. Now, let's get back to our sheep, or rather, to our destiny. We've already said so many times that time isn't universal. It slows down near black holes, speeds up in space, flows differently, even between you and your neighbor, if one of you moves slightly faster. So listen closely. If every point in space has its own unique time, its own tick-tock, what does that mean for a concept like destiny? Imagine, we're used to time being one big wide river, and we all float along it towards some common predetermined finish line. Everyone rows in their own way, but the river is one, and its banks are the same. And if the future already exists somewhere further downstream, then our actions are just an illusion of choice, right? Fate. But what if that's not the case? What if time isn't one river, but an infinite number of streams, each flowing through its own unique landscape? Your stream, my stream, the stream of that star being born right now, somewhere billions of light years away from us. And each of them can bend, speed up, slow down, converge with others, or diverge. Wait, a skeptic might say. What difference does it make? If I have my own stream, it still has a source and a mouth. So my path is still predetermined, it's just unique. And this is where it gets really interesting. We're not just talking about a unique path, but about the very pace of that path changing, that the duration itself of segments of the path isn't universal. That is, the same point in your stream can be simultaneously different points in other streams. It's as if you're reading a book, but each reader turns the pages at a different speed. And sometimes they reach different chapters at the same moment according to their personal clocks. In such a case, can we speak of a single, predetermined plot for everyone? Imagine you're sitting on the bank of your temporal stream, and next to you are millions of other streams, each with its own rhythm. Doesn't this imply that there's no common, rigidly scripted scenario for the entire universe? No master plan for every atom, every galaxy, and every human, if the very fabric of time on which this plan could be embroidered is so dynamic and local? Perhaps if time isn't universal, then the future doesn't lie somewhere ahead, like an already prepared scroll. Maybe it's constantly being created in each unique moment, in each unique point in space, by this very pulsating, living time. Every now isn't just a step along a predetermined road. It's an act of creation. It's as if you were writing a novel, but not sequentially. Rather, in all chapters at once, and each letter, each word, could appear a little earlier or a little later, creating a unique meaning for each reader. Then our choices, our actions, take on an entirely different weight. They don't just fulfill what's predetermined. They shape their own local piece of the future, unique to our timeline. This isn't just a philosophical debate about whether we have free will. It's a question about the very texture of reality. If there's no single, universal temporal highway, then perhaps there's no universal tomorrow written by someone. There are only an infinite number of local nows that constantly give birth to their unique laters. We're not just passengers on this train of time. We are its engineers, each on our own, constantly changing path. Frightening, or on the contrary, incredibly inspiring. Perhaps it's precisely this locality of time that gives us the freedom not just to choose, but to truly create our unique destiny. Imagine this, 1772. Captain James Cook, a legend of the seas, navigates the vast Pacific Ocean on his HMS Resolution. The wind whistles through the rigging, waves crash against the hull, and below deck, in a special box, ticks a marvel of engineering, John Harrison's marine chronometer number 4. Until then, sailors could only accurately determine latitude by observing the stars. But longitude, that was a real headache, claiming thousands of lives. And then Harrison, a simple clockmaker, created a mechanism that over hundreds of days at sea was only off by a few seconds. Just a mere few seconds. This allowed Cook to plot his course with incredible accuracy, map new lands, and ultimately save countless lives. Listen, if you also find it fascinating to delve into these incredible stories where science meets everyday life, don't forget to like and subscribe to the channel. We genuinely appreciate your support. And please tell us, which city and time zone are you watching our lectures from? Write in the comments. We'd be interested to know the geography of our viewers. Now, let's get back to our clocks, which, as it turns out, lie in a way we never imagined. You're probably thinking, so what? What do 18th century navigation and my modern gadgets have to do with this? Well, here's the connection. Your daily life, your car's navigator, your smartphone that shows the precise time, all of it would be utterly useless if we didn't account for those very different times from our previous discussions. Remember, we talked about how time flows differently at different points in space, depending on speed and gravity. This isn't just an abstract theory. It's a harsh reality. Unforgiving physics. Imagine you're driving through an unfamiliar city, rushing to an important meeting. Your smartphone's GPS confidently says, "Turn left in 100 meters." You turn and find yourself in a dead end or an entirely different neighborhood. Why? Because every GPS satellite, circling Earth at an altitude of about 20,000 kilometers, lives by its own rules of time. It streaks along at an immense speed, about 14,000 kilometers per hour. And it's significantly higher up, where Earth's gravity is weaker. And that's where Albert Einstein and his theories of relativity come into play. Firstly, due to the satellite's immense speed, special theory of relativity, their clocks, compared to clocks on Earth, should run slower, by approximately 7 microseconds per day. It's as if the satellite is our little sprinter, falling slightly behind because of its frantic pace. Secondly, because the satellites are high above Earth, where gravity is weaker, general theory of relativity, their clocks should run faster, and this effect is much stronger, by approximately 45 microseconds per day. Imagine gravity is a heavy blanket that slows you down, and the higher you are from Earth, the thinner that blanket, the more freely you move, and the faster your clock ticks. So, we have two opposing forces on time. Speed slows it down by 7 microseconds, while weaker gravity speeds it up by 45 microseconds. Which effect prevails? Simple arithmetic. 45 minus 7 equals 38. 38 microseconds per day. So what, you might say? 38 microseconds. That's nothing. Here's where the main misconception lies. Imagine GPS radio signals traveling at the speed of light. And the speed of light, you know, is about 300,000 kilometers per second. In 1 microsecond, light travels approximately 300 meters. Now, multiply those 300 meters by the 38 microseconds that the satellite gets ahead each day. That results in an error of 11.5 kilometers. Every single day, 11.5 kilometers. Just think about that. If engineers didn't account for these relativistic effects, your navigator would be lying to you by 11.5 kilometers every day. Instead of turning right, you'd end up driving to the next town. This wouldn't just be an inconvenience. It would be complete chaos. Imagine trying to find the right house, and your navigator shows it 10 kilometers away from you. That's why every GPS satellite is equipped with ultra-precise atomic clocks that are constantly adjusted. They literally know that their time flows differently than time on Earth. And these tiny, seemingly insignificant adjustments, 38 microseconds per day, are the key to your GPS working with accuracy down to a few meters. Your car, your plane, your phone. All of them are synchronized, thanks to the understanding that time isn't universal. So, the next time you use your navigator, remember, it's not just plotting a route, it's performing incredible calculations every second, reconciling different versions of time. The time that flows on Earth and the time that flows at an altitude of 20,000 kilometers, where a satellite streaks by. See, these aren't just abstract formulas. This is what allows you not to get lost in a huge city and always arrive on time. This is applied physics of time, which saves us from chaos on the roads every single day. And this is just one example of when your clock is lying, but not because it's broken, but because each of us lives in our own unique temporal bubble. You know, in 1895, when foggy London was enveloped in Victorian melancholy, and the light of gas lamps flickered on wet streets, an incredible visionary, H.G. Wells, released his The Time Machine into the world. Imagine how readers of that era, holding their breath, turned the pages, trying to grasp, could a human truly traverse centuries like a traveler crossing continents? It was pure fantasy, daring beyond belief. By the way, if you, like us, enjoy these incredible stories that challenge conventional notions of the world, don't forget to like this video and subscribe to the channel. It helps us create more content like this. And tell us in the comments, which city and time zone are you watching our lectures from? We'd love to know our geography. Now let's return to our time machine, but not from Victorian novels, rather from a world we only began to understand a century later. Back then, in those days, the very thought that time could flow differently for different people seemed like absolute madness. Time, as everyone knew, was an arrow flying in one direction, identical for all and everything. But you and I already know that's not true, right? We've seen how clocks in orbit run differently, how gravity steals seconds. We understand that every point in space, it seems, has its own unique temporal signature, its own personal, incomparable tick-tock. And what if we learn to control this? What if it's not just a backdrop, but clay from which we can sculpt? Imagine if we could create a localized region where time slows down or speeds up at our will. Not like in the movies, where you get into a machine and press a back to the past button. No, this is about a more subtle, more elegant game. What if it were possible to create a bubble of time, where 1 minute for you equals 10 years outside? Or conversely, where your minute is just a fleeting moment for the external world? Oh, come on, that's pure fantasy, a skeptic might say. There'd be nothing but paradoxes. And they'd be right, if we think linearly, like Wells. If we try to go back and tap our great-grandfather on the shoulder. But what if the ability to travel through time is actually the ability to switch between branches of reality that diverge at every unique moment? You know, like a river that appears as one, but actually consists of billions of individual droplets, each flowing its own way. And what if we could control these droplets, guide them? If every point has its own time, doesn't that mean that at every given moment, a whole array of potential futures already exists around us? Every second of ours is a crossroads, where our decision, our choice, no matter how insignificant, creates a new branch, a new path. Parallel realities, an excellent hypothesis. But instead of merely being another universe out there somewhere, they could literally be here. Just in a neighboring, slightly different, temporal thread that branched off from ours. It's as if you were walking through a field, and every blade of grass, every pebble, had its own slightly different pulse of time. And you could literally step from one version of reality into another, simply by tuning into its unique temporal rhythm. We're talking about time not being a single, overarching mechanism, but rather a complex symphony where each instrument plays its own unique part. And if we learn to conduct this orchestra, to control its rhythm and harmony, could we then not just observe the past or future, but actively shape it? Switch between eras, or even, who knows, to neighboring universes that developed under slightly different temporal laws. Gives you chills, doesn't it? We stand at the threshold of understanding that time isn't just a line, but an entire three-dimensional canvas, each thread of which is a separate story, a separate possibility. And perhaps, in the future, each of us will have our own unique minute. Imagine this. The 4th century AD, the city of Hippo in North Africa. St. Augustine, one of the greatest minds of that era, sits in his cell. Around him, silence, only the rustle of parchment and the flickering of an oil lamp. Outside, the southern sun bathes the Roman streets, and the scent of the sea hangs in the air. And then, in his famous Confessions, he suddenly utters a phrase that echoes down to us across 1,500 years. What then is time? If no one asks me, I know what it is. If I wish to explain it to him who asks, I do not know. You know, in this short phrase lies the essence of the incredible journey we've just taken. And if you enjoy how we're trying to unravel these incredible mysteries of the universe together, please don't forget to like this video and subscribe to the channel. It truly helps us create more content like this. Also, we're immensely curious. Which city and time zone are you watching our lectures from? Write in the comments. We'd be interested to know. Now, let's return to Augustine and his eternal riddle, which takes on entirely new dimensions in the light of modern physics. We began with a seemingly simple premise. What if time isn't universal? What if it's not one wide, calm river flowing identically for everyone living on this planet? Oh, how naively mistaken we were to believe that each of us shares the same clock. We've swept through eras, from the rigid Newton to the ingenious Einstein, from the most precise clocks in orbit to the devouring gravity of black holes. We've peered into the quantum world, where time dances to its own, utterly unpredictable and sometimes even backward-flowing rhythm. And what's the conclusion? Time isn't a universal metronome. It's not a single arrow flying in one direction for everyone. Imagine it's not one wide highway on which all cars race, but rather millions of tiny winding paths, each laid out across its own unique landscape. Your path, my path, a path for every grain of sand on the ocean shore, for every star in a distant galaxy. Every point in space has its own unique temporal fingerprint, its own distinct personal tick-tock. A skeptic might immediately jump up and say, "So what? What difference does it make to me, an ordinary person? My clock ticks as usual, I wind it, and I live by it." But no, my dear, the difference is colossal, because it changes our entire perception of reality. It means your now isn't someone else's now, but your personal, exclusive instant. Your past is just one of countless stories told at different tempos. Your future isn't a rigidly prescribed script, but a field of infinite possibilities, depending on how your unique temporal thread precisely weaves itself. Consider this. If time isn't a giant train hurtling along the same tracks for all passengers of the universe, but rather a complex orchestra where each instrument plays its own part, its own tick-tock, unique to its point in space-time. Your life, your seconds, minutes, years, they are your personal, unique melody in this grand symphony of the universe. Unique, irreplaceable. This is the greatest mystery, the mystery of your unique existence. You're not just a point in space that can easily be replaced. You are a unique temporal string, vibrating to a rhythm that belongs only to you. And realizing this isn't just a dry scientific fact. It's an entire philosophy that makes you look at every moment lived in a new light. Because your moment is only your moment. And it is incredible